Good evening, all of you. Welcome you guys. Welcome you all. Welcome to Unacademy. Welcome to Kreatryx. So let's continue our discussions, all of you, everybody. I hope all of you are doing great and all, everybody. So I hope so. Is my audio video is clear to all of you? And so please do comment. Am I audible to you, all of you? Comment. Am I audible? Is the audio video is clear to everybody? So let's start our discussions, everybody. Chalo. So let's continue our discussions, all of you, everybody. Let's start our discussions. चलिए आज हम डिस्कशन शुरू करेगा सो हियर एंड सबसे पहले बोलिए ना हियर ऑल ऑफ यू प्लीज डू कमेंट एम आई ऑडिबल टू ऑल ऑफ यू इज माय ऑडियो वीडियो इज क्लियर टू एवरीबॉडी इज द ऑडियो वीडियो इज क्लियर टू एवरीबॉडी चलो लेट्स स्टार्ट आवर डिस्कशंस एंड सबसे पहले बोलिए ना अगर कोई डाउट हुआ तो बोलिए सो इफ यू हैव एनी डाउट्स एंड प्लीज लेट्स डिस्कस योर डाउट्स and if you have any doubts, any queries and all, let's discuss. Otherwise we'll continue our discussions. Chalo, meanwhile you post your doubts, we'll discuss. And so here and we have a great announcement regarding the new batches for GATE 2024. For GATE 2024 we are starting the new batches. You can find from the December 21st month today onwards we have started the new batches. And so the first subject we are starting with the networks. As we know, networks is the basic subject, so we are starting the networks. We are starting, and you can find the top educators team. You can find here, right? And you can enroll for these batches, and this is for 2025 के लिए. So 2 years program for the top educators you can find. So December 21st onwards you can starting a new batches. That means today onwards. And so these are the USPs, and so the complete material, so here full coverage of syllabus, and so digital notebooks are available, and practice sessions and doubt session, DPP, special classes and practice sessions and all. Fine. And this is batch for the electrical के लिए. You can find the electrical, you can find the team, the top educators team. So you can use the code of B V Reddy to enroll for it now here. So yeah, earlier was there. We'll see. So I think so here by today we'll finish the electric field topics will finish, and thereafter we are going to do the magnetic fields. Yes. So here when you have seen, so here earlier I was working for ACE Hyderabad. Right. So this thing. Fine. These are the new batches we are starting. You can see the top educators team. Right. And so this is another great news, you know, here. Okay. Boundary conditions. So we'll complete the electric boundary condition, magnetic boundary condition together. Boundary condition topic. So we'll complete the electric boundary condition, magnetic boundary condition together. We'll complete. Together we'll do. Along with the magnetic boundary conditions, we'll complete that one. So this is, I used to follow my order generally, that's why. So so here when I said the syllabus completed, that time you should ask the things. Okay. So here, fine. Let's continue our discussions now here. And these are the new batches we are starting. You do follow these batches. And another most important thing is for GATE 2023 students. GATE 2023 students, this is all India mock test, and this mock test is completely free to all students. Everybody enroll for this thing and attempt the test series. And you can use the invite code BV Reddy. You can use the invite code BV Reddy. Fine. Chalo, let's continue our discussions. Yeah, and let us see some problems also. Now look, take this problem here. Yesterday we have discussed the capacitance analysis हमने discuss किया. So any doubt in the previous classes you tell me. Capacitance concept में कोई doubt हुआ तो बोलिए now इधर. See this thing they given the C naught is the capacitance of a parallel plate capacitor with air as a dielectric. Okay, C naught is the capacitance of parallel plate capacitor when the medium between the two plates is a, now here in this case what the medium is a air. This capacitance they called as C naught. Can you tell me C naught क्या होगा? C naught which is given as epsilon naught A by D. बोलिए. Now what they did now here second figure, there's some part, how much part they filled it now here, you see this thing, half of the entire part is filled with a some dielectric. So here this is having some dielectric से मैंने fill किया, having the dielectric constant, how much they given UTC, and which is equal to epsilon R. Now can you find the capacitance of this second figure? So capacitance of this figure, so which we can just see, which I can call this as, now you tell me now here, this is the distance, now tell me, is the distance changes or no change? Is the distance changes or no changes? Where D is the distance between the two plates, distance does not changes, now tell me all of you. Distance does not changes. If the distance not changes, what will changes, you tell me. So half of the area is one type of medium, another half of the area is some other medium. So that means A will be changes or not. So what I can write now here, this is epsilon which is given as epsilon R into epsilon naught, and A, tell me how much is A, tell me. So this is, now here this part will act as one capacitor, this part will act as another capacitor, now tell me. So this part we can say this part is a capacitor 1 and this is the second capacitor. Hana boliye. It will be two capacitors. Now can you tell me now what type of connection is it, now tell me. Here how the two capacitors has been connected, you tell me now here. So this is a current, we can give the connection like this now. Now this current coming like this and the current will go here like this. Can you tell me what type of connection is it now here? Yes, now here this part, some current will go in this path, some current will go via this capacitor, says some current will go via this capacitors. Now the two capacitors are connected in parallel now. Then what is the equivalent capacitance, you tell me. C is equal to what I can say here, C1 plus C2 hoga na, tell me. Hana boliye. So which is given as C1, tell me now, this is a free space. C1 is a, what you tell me, this is a free space now, air. So tell me what I can say now here, epsilon naught A is what you tell me now, A by 2 now, it will becomes 2D hoga. Half of the medium is air only, plus C2 tell me, that is epsilon R epsilon naught area of होगा ना, tell me 2D. चेक करिए. Now this overall capacitance which is given as, tell me now here, and which is given as epsilon naught A by 2D into 1 plus epsilon R. बोलिए. Now tell me the capacitance now here. So we can say the new capacitance which is given as this part, which we can write it as C naught by 2 into 1 plus epsilon R. C naught by 2 into 1 plus epsilon R. Tell me this thing. So what's the option? Tell me now here. Option A. Over. Done everybody? Chalo. Here's another problem. Yeah, this is one good problem. This is, I think, GATE 2014, I think so, this problem given for electrical. So this is one good problem. Look at now all of you. So read the problem carefully. Read the problem carefully, try to understand. So a parallel plate capacitor consisting of two dielectric materials as shown in figure. Two dielectrics. Now here this part is one dielectric, this part and this part is same dielectric. You see this thing, this is epsilon 1 and this is also epsilon 1, and this part is second type of medium, that is epsilon 2. Okay, the middle dielectric slab is placed symmetrically with respect to the plates. The middle dielectric is placed symmetrically with respect to the plate, exactly symmetrically bola. That means what I can say, tell me now Ida. So here this total it was given as d by 2. Can you tell me how much iska length, this width kitna hoga boliye? So this, which we can call this as a d by 4. Hana boliye. And this part is d by 4. This is one crucial point to understand. Is it fine? This point clear to all of you? The dielectric slab is inserted symmetrically with respect to the two plates. So that's why d by 4, d by 4. Boliye. Next. And so here this is connected to ground. That means this voltage 0. So means this voltage on this, which is equal to 0 volts now. And here they given, so here they given this as a 10 volts given. Here they given 10 volts. Read the statement here. एक बार ध्यान से read the statement. What they given now here? What they given here? They said, so here this is the capacitor we have first of all. So it has consisting of a two dielectric they are saying. And what they said, you tell me, look at now here. The middle dielectric slab is placed symmetrically with respect to the plates. The middle dielectrics are placed symmetrically with respect to the plates. And you see this thing, what they are saying is the middle dielectric, this is the middle dielectric. So then iska width diya na here, how much the width of this part is given, you tell me. This width is given as d by 2. See this thing here. This width which is given as a d by 2. Hana boliye. This is d by 2. That means baki total width is how much? Total one is a d. So you tell me now here. What they are saying is so this width, this part of width is already given in the problem, that is d by 2. So agar ye d by 2 hai to then what about this part, you tell me? Symmetrically they has located na, exactly symmetrically they has located. Hana boliye, they are located symmetrically. So then isko ye kitna hoga now here? This is d by 4 and this must be d by 4, and this is one medium epsilon 1 and this is also epsilon 1 and this is epsilon 2. Everybody, that's what I have written. That is our crucial point. And what else they given? You see this thing here. So they have mentioned this is connected to ground, means this voltage 0, this voltage 10 volts. And what is other given? The potential difference between one of the plates and the nearest surface of the dielectric is 2 volts. What is meaning it now here? The potential difference between one of the plate and the nearest surface of a dielectric is given as what? Given as a 2 volts. Means अगर मैंने ये plate consider किया तो if I have considered this plate, if I consider this plate now here, So the potential difference between one of the plate and nearest surface of a dielectric. Nearest surface. Now this is the nearest surface of a dielectric for this plate. Now tell me how much the potential, इसका बीच का potential difference कितना बोला? So that is 10 volts. So sorry 2 volts बोला ना. So this is 10 volts means here it should be 8 volts होना पड़ेगा बोलिए. So that means this must be 8 volts. Is it fine? Now here they didn't mention the left plate or right plate. So then what I need to do here, if I consider this plate we have considered, the potential difference between one other plate and the nearest surface for this plate is A na here. They given that is 2 volts means this is 0 means it should be a 2 volts ऐसा होना पड़ेगा बोलिए. दूसरा पॉइंट आप ध्यान देना पड़ेगा. ये सेकेंड पॉइंट भी आपको समझ में आया? So these two are the crucial points in this problem. अगर ये बात आपको समझ में आया तो प्रॉब्लम खत्म. These are the two crucial points. And first of all of you do like the session, everybody. I didn't find the likes in this class. All of you do like the session first of all. चलिए, done. All of you do like the session. Fine. Now you can tell me now here. So हमको होगा ना. Now we need to find what now here. Epsilon 1 by epsilon 2 is required. Epsilon 1 by epsilon 2 is required. So अभी बोलिए क्या करना पड़ेगा? You see this thing here. Now can you tell me now how this? So here because of the division I can treat this as one capacitor C1. This is the C2. This is C3. Can I treat like this? Tell me. C1, C2, C3. So अभी ये तीन capacitors हो गया ना? Tell me. Can you tell me now what type of connection this capacitors was made? How this capacitors has been connected? You tell me. How these capacitors are connected? How these capacitors are connected? So we'll take the terminals like this now. Isn't it? How the capacitors are connected? You tell me. अगर मैंने इस इधर एक करंट I किया, so इधर भी करंट I होगा ना? Tell me. How the connections? The capacitors are connected in series ना here. अभी बोलिए हमने previously कुछ कहानी डिस्कस किया series connection में. If it is series connection क्या होगा? Tell me. Series connection current. If it is series connection, whatever the current you tell me, current is same होगा कि नहीं? Current same means charge same. Series connection, current same means charge same. हाँ ना बोलिए. अगर आपने ध्यान से देखा तो इधर. So what I can do? Tell me now इधर. If I call here in this region the charge, I am calling this as a Q1. And if I call the second region, this charge is Q2 and this is Q3. If I call, can I say that all the charges are barabar? Can I say that all the charges are equal? बोलिए. So here Q1 equal to Q2 equal to Q3. हाँ ना बोलिए. Since these are connected in series, so charge तो same होना पड़ेगा ना here. So let us simply find the charge of each capacitor हम find out करेगा ना बोलिए. Now tell me now here Q. What is the basic formula here? Q formula. Q is equal to what we can say CV. And so that means Q is equal to CV and C is equal to what I can say now here. Epsilon A by D होगा. Exactly. Epsilon A by D होगा ना. C is equal to epsilon A by D. Now अभी बोलिए अगर मैंने Q1 लिखा तो Q1 is nothing but what we can say this is epsilon 1 A. What about the area of the plate now here? Is the area of the plate remains same or changes? Is the area of the plates remain same or changes? Is the area same or changes here? Each plate area same or not? Same ना here. D means what we can say? इसका बीच का distance how much now here? This is D by 4 ना? Distance. इधर ये distance कितना? This is D by 4. And then what now? Potential. What is the V in the formula of capacitance now? Potential or potential difference? What is the V means? V means what, you tell me? Potential difference. What is the V means what? Potential difference. Potential difference between the two plates ना? How much the potential difference between these two here? Tell me. इसका बीच का potential कितना? How much here? Which is equal to? Tell me now here. Which is now? Tell me. बोलिए बोलिए. So that means so हमको Q1 मिला ना? बोलिए. So we got the, and which is given as 8 epsilon 1 A by D. 8 epsilon 1 A by D. Next, tell me now Q2. Next, tell me Q2. Q2 which is given as what we can say now here, C2 into V2. C2 into V2. Tell me now here. So here which is given as Q2. C2 means this capacitance are the second. This capacitance now tell me how much we can say this is. Epsilon is epsilon 2. ये no changes ना here. And what are the D now here? D by 2 ना, इसका gap कितना? So this distance is D by 2. And then V2 means the potential difference between these two now here. How much the potential difference between these two? 6. So from this what I will get my Q2? Tell me here. Yes, which is given as a 12 epsilon 2. 12 epsilon 2 A by D. Done? Now what we can say here, we got the C1, C2, Q1, Q2s we got. So even if you want, you can find the Q3 also, but again, so Q1, Q2 directly I can equate now. Tell me. I can simply equate the Q1, Q2s. Yes or no? So that is given as Q1 equal to Q2. Simply equate, get these values. Q1 हमको क्या आया? 8 epsilon 1 A by D. 8 epsilon 1 A by D. And which is equal to 12 epsilon 2 A by D. So simplify, get this value now here. So this is D ने D को मारा, A ने A को मारा. So 4 2s, 4 3s now tell me. So tell me how much will get epsilon 1 by epsilon 2 कितना आएगा? 3/2. Done? So which is equal to 3 by 2. Yes, like this we need to solve these problems on these capacitors. मैंने so here series connection में parallel connection में दिया ना. So once you remember those things, the analysis, the cycle they given na, the loop, then you can easily attempt the problems. Chalo. Next one, dielectric strength. Next one, dielectric strength. Dielectric strength, so generally this is similar to, this is like a breakdown. In the networks we used to call this as a breakdown. हाँ ना बोलिए. Networks we used to call breakdown voltage, isn't it? So what is the dielectric strength here? As I have discussed it now here. एक बार ध्यान से देखो इधर. Now you tell me now here, as we have discussed now here, this is my electric field. This is my electric field. When you apply, see what happens now here, and one side positive charges will come here. One side positive charges will come. हाँ ना बोलिए. Other side negative charges will go. Other side we have negative charges will be there now. As a result, we have discussed that now a pair of positive negative charges will be formed, I can say. A pair of positive and negative charges will be formed. So this pair which is called as a dipoles. हमने ये कहानी हमने पहले डिस्कस किया. ये कहानी हमने पहले डिस्कस किया. देखो इधर, अगर आपने ध्यान से देखो. Now if we observe carefully, here this is the positive charge is there now, this positive charge. ये positive charge, you tell me now here, this positive charge, why this positive charge is not moving to this side? Why this positive charge is not moving to this side? This side, why this is not moving to this side, I am asking. Why this is not moving to this side? Because what happens now, this positive charge will experiencing a two forces. Yes or no? So this is what you tell me now here, this positive charge, because of this electric field, and this positive charge will repel this positive charge now. Because of that two forces, the charge is not moving. अगर आपने देखा तो this the positive charge, consider here. Now on this positive charge you see the forces now here. This is my externally field, right? External field, and here, but here this is a repulsing force now, repulsing elect force is there now on the charge. हाँ ना बोलिए. So this is a induced field. This is what you tell me now, this is what I can say now here, induced field. The induced field is this direction, or tell me opposite the electric field. Ana boliye. So that's why here, so this charge is at rest. Fine, all of you. Now the charge will experience the two forces. One is because of externally applied electric field. This is the externally applied electric field. External field, and this is induced field. अभी बोलिए क्या होगा, क्या होगा. Now मैंने क्या किया, so here what I am doing now here, मैंने this external field को keep increase किया. I am increasing to keep on increasing. Then क्या होगा, you tell me. Now when I don't, at this situation you tell me now here, so the charge experiencing a force from the two directions. That means, and this force and this force, these two are balancing. Hana boliye. Now these two forces are balancing. That's why the charge is at rest. Hana boliye. Why the charge is stationary? So since the two forces are acting simultaneously, those are yes, those are what now here, balanced. That's why the charge is at rest. Now what I am doing is, now I am keep on increasing my the external field को increase किया, बहुत ये ज़्यादा किया मैंने, very large value increase किया. Then क्या होगा? Then what happens now here? My, because of this external field, my this whatever we have the charges. Yes, what happens now here? Now if I increase this thing here, now this force is very high compared to this induced force or not? Then as a result, this, because of this high electric field, the charges will move along the direction of electric field. The charges, that means in that case it will break this electric dipole, and the charges will move along the direction of electric field. This situation is called as a breakdown. This situation is called as a breakdown. It will overcome this induced electric force, and it will move towards the direction of electric field. That situation is called as a breakdown. And the maximum electric field we can apply so that breakdown cannot happen. That is called as the dielectric strength. That's what you can see now here. If you see carefully, अभी जो हमने डिस्कस किया, if the high electric field is applied across a dielectric, what happens? the electrons get separate from the molecules and dielectric behaves as a conductor. Now this is no more the dielectric, it will behave like a conductor, and this phenomenon is known as a dielectric breakdown. The maximum value of electric field that a material can withstand without breakdown is called as a dielectric strength. The dielectric strength, so we'll denote with a letter of E, which is given as breakdown voltage by D, where D is the distance of separations. D is a distance of separation. Okay. What a breakdown voltage? What is a breakdown voltage for the air? That is 3 into 10 power 6 volts per meter. Neutral in the sense means what here? Neutral means what now here? If you take this, any atom is always neutral. And if you take mobile, whatever the in the universe we have taken, that is what you tell me, that is neutral only. Yes, any atom, you take a mobile, pen, whatever we have taken, that is a neutral only. What is the meaning of neutral, you tell me? What is the meaning of neutral? If it has an equal number of positive charges, equal number of negative charges, then we can call that is a neutral. Equal number of positive charges, equal number of negative charges, that is called as a neutral. Every atom hamesha neutral, no doubt at all. Atoms are always neutral only. Atoms, any atom is always neutral only inside. So what should be now here? If you have taken this thing, this is neutral, but thing is, what's going to happen, you tell me? If we have this, is we have one positive charge here and this is a negative charge we have, this is neutral. Equal number of positive charge, equal number of negative charge. But what happened, you tell me? When we apply some electric field, this direction when you apply, so this positive charge will move to here, this positive charge will move to here, this negative charge will move to here. But this atom, the charges inside this molecule will be come out. Will this fellow charge will बाहर आएगा क्या? Yes, ये चार्ज है ना अंदर, ये चार्ज बाहर आएगा क्या? ये कभी भी नहीं होगा. So those are always inside only. So those molecules, the charges does not come outside hamesha, remember. So that means what now here? Now this is without applying, before applying electric field is neutral, after applying electric field also neutral only, na tell me. Atom hamesha neutral, so never think about like this. Neutral is different, the moment of charges is there. So but neutral concept is different. Equal number of positive, equal number of negative, bus. Done. So what is the dielectric strength of air? 3 into 10 power 6 volts per meter. Fine, all of you? Chalo. Electrostatic energy. Electrostatic energy. Here WE, yes, WE, which we are calling it as a electric energy density. WE, which is called as a electric energy density. WE is called as what? Electric energy density, with a units of joules per meter cube. Energy density, which is defined as a energy, and W I am calling it as a electric energy. W is called as a electric energy. And what is the relationship between the energy and the energy density? energy and energy density here. The electrostatic energy density, which is given as, this is given as energy per unit volume. Energy per volume is called as a energy density. Energy per volume, dV is a differential volume, is called as energy density with a units of what you tell me now here, joules per meter cube. The electrostatic energy density, which is given as 1 by 2 d dot E. 1 by 2 d dot E. Electrostatic energy density, which is given as 1 by 2 d dot E. Fine, all of you? Electrostatic energy density, which is given as 1 by 2 d dot E. Done? And with the units of coulombs per meter cube. Now, if I know the energy density, how we can get energy from energy density? By volume integration. By volume integration of energy density will give energy. So then from this energy, which is given as, what we can right now tell me, volume integration of 1 by 2 d dot E na d bar dot E bar into dV. So which is given as, what I can say, now this 1 by 2 is a constant integration of, what I can say here, as we know that d is equal to epsilon E na. So then it will becomes, what we can say, 1 by 2, this is epsilon E square hoga na, E dot E is a E square into dV. Then now this is an energy. This is general formula we use to find the energy of a electric field energy. This is 1 by 2 epsilon E square into dV. Now let us see, now this formula I am doing a little modification. I am doing now here. Let us doing some approximations. Right. You see this thing here. Now if I assume that E is a constant, then I can take outside now. If I consider this E is a constant, that means uniform, then I take this is outside the integral, we can get now here, that we can say 1 by 2, this is epsilon into E square, and the volume integration of dV, I can write this as a volume, I can write now, volume of a given figure. So then, so which we can say now here, as we know that E is equal to V by D, this relationship between the electric field and potential, and the volume I am writing this thing as surface area of cross section into length I am taking as a D. Can I use these two substitutions in this formula? Then see what I will get now here. E is equal to 1 by 2, this is epsilon into, we can say this as V by D whole square, volume is given as A into D. Now tell me finally what I can say here. 1 by 2, 1 D will get cancelled, that is epsilon A by D, into V square, epsilon A by D into V square, I can say, tell me all of you. This is the energy formula. So आप ये फॉर्मूला देखा, कभी भी देखा क्या ये फॉर्मूला? is given as, this is 1 by 2 CV square. Ana boliye, this is the energy stored by the capacitor. Capacitor will store what type of energy, you tell me? Capacitor will store what type of energy? Electrostatic energy only na, that is a formula. Done. This is the way we have derived this formula. Done. Chalo. Yeah, take this problem. A dielectric slab of 400 by 400 cross section and 0.4 meters long. The slab is subjected to a uniform electric field is given kilovolts per millimeters. The relative permittivity of a dielectric medium is given as a 2. Now they are asking to find the energy stored in the dielectric. Now they are asking to find the energy stored in the dielectric. Now you tell me now here. Abhine dekana energy. So which is given as, tell me here. Which is given as integration of volume integration of 1 by 2 epsilon E square into dV. This is the energy now. Here if you see this thing, this is electric field which is a uniform electric field, a constant field. So we can modify this formula as, tell me now here, 1 by 2 epsilon E square into, I can say this as a volume. Boliye, into volume I can write. And so here what is this E here? E given as what, you tell me? Electric field which is given as, now this is 6AX plus 8AY and this is kilovolts per millimeter given now. So can you tell me the magnitude of E, which is given as square root of what we can say now here, 6 square plus 8 square. That means magnitude of E, which is nothing but what we can say here, 10, isn't it? 36 plus 64. And they given the kilovolts per mm. That means what we can say here, this is 10 cube volts per mm means what we can say here, 10 power minus 3 into meters hoga na. So from this, how much this electric field, you tell me? That is 10 into, this is 10 cube into, and this is another 10 cube. Now this is a volts per meter. Hana boliye. That means this is totally 10 power 6 plus 1, 7. So that means energy which is given as 1 by 2 epsilon. And so what is the epsilon value we know now here? 8 point. They given dielectric constant has given na. Having dielectric constant 2 is given. So that means what we can say, epsilon is given as epsilon r into epsilon naught. That is 2 into, this is 8.854 into 10 power minus 12, and E square means how much, you tell me now? 10 power 7 means 14 into volume. Volume means area of cross section into length. This is the area of cross section will come now. That is how much, you tell me? 500 into 400. These are the millimeters now. Both are milli. So means what I can write now? This is 10 power minus 6 into, this is the length. How much this length, you tell me now here? 0.4. Boliye. Yeah, simplify and tell me the answer क्या आएगा. सिंप्लीफाई करके बोलिए क्या आएगा. ये 2 ने 2 का मारा. Done. So this is how many zeros you need to see carefully. Here we have, this is what now? 14, 15, 16, 17, 18. 18 zeros, and this is this also 18. So this means a zero, सारा zeros cancel हो गया ना, tell me. and this 5 into 5 25, 25 into 4.4, which will be a 10. So what I will get, to tell me finally? This means 88 now, isn't it? 88.5. चेक करो all of you, चेक करके बोलिए ये आया सभी को, चेक करके बोलिए कौन सा ऑप्शन? ऑप्शन सी, isn't it? बोलिए. Done. Yes. Next one. Equipotential surface. Equipotential surface. What is meant by equipotential surface? Equipotential, the name itself indicate, potential तो same होना पड़ेगा. The surface where the potential is same. So here if I join all the points, and we can get some locus will form, some shape will form. That shape is called as a equipotential surface. The shape is called as a equipotential surface. Now, where the potential is same, and if you have taken some surface, we have taken, consider, we have taken some surface, we have taken. Now if I call this is my equipotential surface, if I call this is a equipotential surface, इसका मतलब क्या है? This is a equipotential surface means what you tell me now here, the potential everywhere is same now. Now I have taken this point, 2 points I have taken, A and B have taken 2 points in the surface. Now you tell me now here VAB or VBA. So potential difference between these two, how much you tell me now? 0 now. Potential difference between these 2 points, which is equal to 0. Now let us say that I want to move some charge from here, A to B. A to B. If I want to move the charge now, how much is work done? Work done, which is given as minus Q into change in potential. Now tell me. Work done is equal to minus Q into change in potential. So change in potential, which is equal to 0. So that means how much the work done, you tell me? Work done equal to 0. So means what we can say, work done in moving a charge from one point to another point in the equipotential surface is 0. Work done in moving a charge from one point to another point in the equipotential surface is what? 0. ठीक है? Right. Now consider I have taken some positive charge plus Q I have taken. Here we have one charge I have placed now here. अगर आपने ध्यान से देखा तो here from this charge to this thing some distance. Let us call this distance is something R I am calling. R. So here, so we have some potential. Now in this direction, equal distance of R, how much the potential at this point? How much the potential at this point? Same or different? How much the potential at this point now here? So यहाँ से यहाँ तक कितना distance is R? यहाँ से यहाँ तक कितना distance है? वो भी R ना here. Now you tell me now here, potential same or different? And in this direction at a distance of R, so potential same होगा ना? Yes, ये भी potential same or not, you tell me. So potential तो everywhere is same. Now we have taken randomly, we have taken. Now I can take my point ऊपर भी ले सकता, नीचे भी ले सकता. I can take my points are ऊपर नीचे, so many all around we can take or not. By joining all these points, now can you tell me what the shape I can able to form? हमको कौन सा शेप मिलेगा? By joining all these points now we have taken now here, नीचे ऊपर सारा मैंने मिला के मैंने एक शेप बनाया. So can you tell me now what the shape I can form? Can you tell me what the shape I can able to get? You tell me now here. So here tell me, will form the 2D figure, will form a 3D figure we can form. देखो here not, so here ऊपर नीचे भी हम points ले सकता ना. At a distance of r we have taken, potential तो same है ना, ऊपर नीचे भी ले सकता कि नहीं? And we taken only left right we can take, ऊपर नीचे नहीं ले सकता. ये सकता यहाँ along z axis also we can take ना points now. उधर भी so same होगा कि नहीं? So that means what the shape we can form, you tell me. This is a 3D figure we can form now, that is called as one sphere. We can form a sphere, we can form now. Now from this what we can say now here, at each location my potential is same, I can say now. At each location I can say my potential is same. So that means the equipotential surface for the point charges, is what? Sphere. Point charges is what? Sphere. अभी देखो इधर मैंने so here इतना radius से मैंने एक sphere बनाया. So can I change, if I change the radius now here? Yes, यहाँ से भी हम एक sphere बनेगा, बोलिए. This is also one my equipotential surface, I can say, tell me. This is also my equipotential surface, ये भी sphere होगा ना. And भी से भी हमें equipotential surface बनेगा, यहाँ से भी. Yes, this is also my equipotential surface only, tell me. All of you बोलिए. Like this. So we can say, so what I can say, equipotential surface for the point charges is what I can say, concentric sphere. Concentric spheres. Like that we can form so many equipotential surfaces we can form. Done. And one more thing here. अगर आपने ध्यान से देखा तो here, if we have a charge here, now can you tell me this is a positive charge we have taken? So I can draw the electric field lines, I can draw. We have electric field lines are like this or not? These are the electric field lines. What I should call now? These are what now here? Electric field lines now. Now can you tell me now what is the angle between the electric field lines and the equipotential surface? How much? What is the angle between the electric field lines, electric field, and the equipotential surface? This is the equipotential surface now. This is the equipotential surface. Tell me what is the angle between these two? What is the angle between these two here? Tell me what I can say, 90. So from this what we can say now here, the electric field lines cuts the equipotential surfaces orthogonally. Electric field lines cuts the equipotential surfaces normally. The angle between the electric field lines and the equipotential surfaces are normal to each other. Then अभी ये पॉइंट्स आप लिखो. अभी ये पॉइंट्स आप लिखो. Properties of equipotential surface. The work done in moving a charge. How much the work done in moving a charge in the equipotential surface? Tell me. Work done in moving a charge in the same equipotential surface is 0. हाँ ना बोलिए. Will the two equipotential surfaces cross each other? Will the two equipotential surfaces intersect each other? कभी भी intersect होगा क्या? So two different equipotential surface means two different potentials now. How the two different values will meet at one point? How the two different potentials will meet at one point? एक कभी भी नहीं होगा ना? It never happen. Now, how the equipotential surfaces for the electric field lines? So here, how the equipotential surface cuts the electric field lines are orthogonal na? Electric field lines cut the equipotential surfaces perpendicular to each other. Will cut the orthogonally. Next. And what are the equipotential surfaces for the point charges? Point charges is the concentric spheres. Point charges is a concentric spheres. And line charges is coaxial cylinders. Line charges is concentric or coaxial cylinder. Equipotential surfaces for the line charges is a coaxial cylinders. Okay. Done? Yes. Fine. Okay then. Yeah, with this we have finished the electric fields. हमने finish किया. With this we have finished the electric fields. In the next class we'll start the magnetic fields. Next class we'll start the magnetic fields. Okay. Fine. That's for the today's session. All of you do like and do follow me in the Unacademy special classes and plus classes. Free classes you can able to access. I did the mass, EMF, networks, signals, controls, digital I did. So daily we have a digital classes running daily 11 o'clock. You can attend the classes. Okay then, see you, bye bye, good night.